Last part of multiplying fractions is multiplying mixed numbers. So not a whole lot changes. You just need to first know that you have to change the mixed number to an improper fraction. Then you can multiply. And again, remember, my suggestion is that you cancel with the greatest common factor so you can work with much smaller numbers. And now that's not going to work every time. It's something you certainly want to look for. And then after you get your canceling done and you've multiplied across, you need to change that final improper fraction back into a mixed number. All right, so getting into some examples here. 3.5 times 5. So I need to change 3.5 into an improper fraction first. So 3 times 2 is 6, plus 1 is 7, over 2 times 5. And remember, we're going to put a whole number over 1. Check to see if there's anything I can reduce. There isn't. So I do multiply across, 35 over 2, and then change that back into a mixed number, which it goes in there 17 times with 1 left over, and my 2 stays the same as my denominator. Going on to the second example, now we have a mixed number and a fraction. So my improper fraction is going to be 17 over 4 times 5/6. All right, and remember, I cannot reduce numbers that are on the bottom or both in the denominator. They have to be diagonal to one another. And so in this case, again, I don't have anything I can reduce. But 17 times 5 is 85. And then I get 24. Doing some mental math here, I know 24 goes into 85 3 times, which is 72, which gives me 13 left over. And then 24 in my denominator. And lastly, we have a mixed number times a mixed number. So 1 times 3, 3, 5/3 times 8, and 3 is 11 over 4. So now I'm going to have to multiply across to get 55 over 12. And then figure out how many times does 12 go into 55. That's going to be 4 times, which is 48, 7 left over, with 12 as my denominator. All right, so again, really nothing changes. You just need to make sure that you change those mixed numbers to improper fractions first before you multiply. Some harder problems here. Getting into 12 times 5 is 60, plus 3 is so 63 over 5 times 7 over 3. Now, this is where the cancel method, and just taking a second to look at it, 3 does go into 63, it goes in 21 times. So now my numbers are a little bit smaller than I'm working with. Still not nice numbers that I can do in my head, except this one I might be able to, because 20 times 7 is 140, 1 times 7 is 7, so 147 over 5. And when I divided this out, I end up getting 29 2/5 as my final answer. Then, if I look at 5 3/8, if I change that into an improper fraction, I get 43 over 8 times. I'm going to have 42 over 5. Now, 8 and 42 are both even numbers, so I know that I can cancel at least a 2 out. So I get 4 here, and I get 21. Now, when I multiply across, I'm going to have 20 in my denominator. 43 times 21 ends up being 903. Doing my long division problem, I end up with 45 and 3/20 as my final answer. All right, so your answers are going to be much larger when we have mixed numbers, especially when we're working with some irregular fractions, not normal ones like 1/2, 1/4, and so on and so forth. Lastly, some word problems. The average eyeball of the eyeball of an Atlantic giant squid is 12 times as large as the average human eyeball. If the average human eyeball is 1 1/4 inches across, about how big is the Atlantic giant eyeball? Well, I would do 12 over 1 times, making this into an improper fraction. I would get 5 over 4. Checking to see if there's anything I can cancel, and I can. Goes in there 3 times. So the word about, there is a way that you can, in math, write it's a squiggly equal sign, which means approximately or about, when I multiply across 15 inches as my final answer. Then lastly, Mr. Kibbe is laying brick to make a rectangular patio. The area he is covering with bricks is 15.5 feet by 9 3/4 feet. What is the area of his patio? So changing those to be improper, I would end up getting 31 over 2 times 39 over 4. And so here there's nothing I can cancel, so I basically just have to multiply across and divide. So 8 is going to go here, and I get 1,209. When I divided this out, I ended up with 151 and 1/8 feet squared. Okay, so a lot of construction people are going to need to be able to work with fractions and be comfortable changing them into mixed numbers and so on and so forth, so they can figure out the total square footage that they would need. So there's a real world example for you. So when you're a homeowner, make sure you know how to do this when you want to get a new patio.